Welcome. We're going to talk about word problems with rational functions today. In class, we created a foldable by taking 3 pieces of paper, slightly offsetting them, and then folding them down, so we ended up with 6 flaps here. Does not matter the order, staple them along the top. Okay, and the names of these flaps are what we're using. The title of the whole brochure is Word Problems with Rationals. When we lift that up, we're going to have inverse variation. So let's work on inverse variation right now. And there was a problem that was handed out that we will glue in. And this is what we did in class the previous day, inverse variation. And our inverse variation, our generic equation is y is equal to k over x. K is called your constant of variation. X is what you vary, and y is the dependent variable. So as you change x, what happens to y? Now if I was trying to solve to find k, we need to get the denominator to be 1. So to get rid of the x in the denominator, I multiplied both sides by x. My x's cancel, so now I have x times y equals k. And remember, k is a constant. So any combination of x times y equals k. So what we're going to use here is the violin string is 14 inches long, so that's x. 14 multiplied by the frequency is y, so 450. 14 times 450 gives you your constant of variation. And in this case, 14 times 450 is equal to 6,300. That is my constant of variation. Now I need to find what happens if I varied the length of the string to be 12 inches. So I have 12 inches produces some variation, but my constant is still 6,300. So to find y, I need to divide both sides by 12. So we'll get y is equal to 6,300 divided by 12, which is 525 cycles per second. And again, one thing to remember is since x times y equals k, no matter what the x and the y are, I could also set up a second equation if I don't care about my constant. The first x times the first y is equal to your second x times your second y. And if you don't care what your constant is, this is a quicker way to solve that. Okay, our second tab, coming back to over here, we did our inverse variation. Next one is simultaneous tasks. So let's take a look at the problem we have here. Oops, let's make this so you can see. So simultaneous tasks. In this case, I've got a pool, and I'm filling it with pipe A, and it takes 18 hours. If I used pipe B, that would take 12 hours. But I'm curious, how long will it take together? We're also throwing a little wrench in this, that someone forgot to close the drain. So the drain is open also. The drain can empty the whole pool in 8 hours. So we wanted to see, could we set up an equation if both pipes were working and the drain was open, how long would it take to fill? So our generic equation for simultaneous tasks, we would have x over a plus x over b. And if you have more than 2 people working together, or 2 pipes, another x, and that can go on as many different people or pipes that you have, equals 1. And let's talk about what each of these things represent. X represents your time if people are working together. So all of these x's are exactly the same. This is the combined time. If person A or pipe A are working, person B or pipe B is working, or person C. So if everyone is working at the same time, x represents the time it takes everyone together to work. A is the amount of time that the individual takes. So individual A, how long it takes them. Individual Person B, how long does it take person B to do the job by themselves? C is how long it takes person C by themselves. So if we're looking at our example here, I don't know how long it takes altogether. So x will stay in my equation. X over something plus x over something equals 1. Let's shrink that so you can see. Okay, so individual A, or pipe A. It takes pipe A 18 hours to empty the pool. So that's what I put in my denominator in the first fraction. The length of time it takes person A. The second fraction is the amount of time it takes the second person, or the second pipe in this case. So pipe B takes 12 hours if it was working only by itself. So we'll put that in there. We don't have a third pipe, we have a drain. And keep in mind that drains work the opposite of pipes. They're emptying the water out. So instead of adding to this, we're going to subtract it because it's working against these two pipes. So my third instance is the drain, and the drain takes 8 hours to empty. So let's just note that that was pipe A, pipe B, this was our drain, and this is the time together. You'll want to solve this problem. In our next class, we'll talk about how to solve this.